In this lesson, 2.11.b, we will be interpreting quadratic graphs. Our objectives are to interpret graphs of given real-world phenomena. So as you can see, many things in life are shaped like an arch and they have a quadratic function. So we can model this bridge with a quadratic function. We can also model other things like tunnels and arches and even jumps or the way we throw things using quadratic equations. Let's go ahead and look at our example using a bridge. In this first problem, this is the New River Gorge Bridge in West Virginia. It's the world's largest steel single arch bridge. This bridge, or this arch, I should say, can be modeled with the function y equals, let's go ahead and highlight it, y equals negative 0.000498 squared plus 0.847x. So this arch has the equation of y equals all this. What we know is that x and y are in feet, and it tells us here. But what we're trying to determine, two things. How high above the river is the arch? So the distance from the river all the way to the top of this arch. We also want to determine how long the section of bridge is above the arch. So we are trying to find from here, let's say, all the way to here. So what is that distance? Well, luckily we understand how to find certain things in a quadratic equation from the last lesson. We understand that if we take this semicircle or this arch, we can determine this point here. Because this point here is going to give us our vertex. If we can determine the vertex, we will be able to determine this height in here. If we know this height in here, then we can sum these two heights to determine how high above the river this bridge, the arch, really is. We can also then determine perhaps how long the arch is, and I will show you how to do that as well. So let's go ahead and tap into our knowledge, our toolbox, our skills. If we have a quadratic in standard form, which this is, we have y equals a, which is negative 0.98 x squared, plus b, and the b is 0.847x, plus c. And notice we don't have a c. C is 0 in this case. And that's okay because it's still a quadratic by the fact that it has an exponent of 2. So we can use a quadratic in standard form, and we know how to find the axis of symmetry. It basically would run right along where these yellow arrows are. So let's go ahead and find the axis of symmetry first, as that'll get us towards our vertex. So remember that it's negative b over 2a. And we said that our b value was this 0.847. So we'll say negative, and I'm just going to say 0.847. And that is divided by 2 times our a. And our a value is this negative 0.000498. Okay, so what I want to do is simplify this because I don't really know what this is unless I can simplify it. So I probably will need a calculator to do this simplification. So let's pull the calculator out and let's do a little math. Let's go ahead and simplify the denominator first. So we'll leave the numerator like it is. We know the denominator is going to be negative. A positive 2 times a negative is going to be negative. So 2 times 0.000498 gives us this 0.000996. And then let's go ahead and simplify it a little bit more. So let's divide these out. 0.847 divided by 0.00096. All right, great. So that makes a little more sense to me. 882.29, we'll go ahead and round to the hundredths place. And this is feet. We'll save our calculator. Put it up here for now. So we know that the distance from here to here is going to be 882 feet approximately to get to this mark here. That is our x-coordinate. But what we really want to know is how high this is. Well, if we know the x-coordinate, we can definitely determine the y-coordinate by just plugging it in for x. So in our equation, we have y equals negative 0.000498 times 882.29 squared. So I'm just plugging in our x value in order to figure out our y value so we can actually get the vertex. So 0.847 times this 882.29. All right, so we're going to do this in our calculator first, or the whole time actually. So let's do our exponents. So we have 882.29 and we're going to raise it to the second power. So we get that. Now what I'm going to do is go ahead and write this in here. It's a very big number. 778,438. I'm going to again round to the hundredths place. And then we have this other stuff, which I'll continue to write out. We have a lot of big numbers. So what I like to do is go ahead and leave this in my calculator without rounding it and then multiply it by this number here because that would be the next step. So if I just hit times, it'll take what's in here and multiply it by this number here, 0.000498, and I should get a smaller number now. And now remember that it's going to be negative because there's a negative right here in front. So I get negative 387.66 plus, and I'm going to go ahead and multiply these numbers out now too. So let's do that. 0.847 times 882.29. 747, and then I'm going to round to the hundredths place, which would give me 0.30. Okay, so I've got these numbers, and now I'm going to combine those. So from this 747, I would want to subtract, because of the minus, the 387.66 to give me a y value of 359.64 feet. So great. What we know now, if I look at my graph here, is that the height, we're going to move our calculator over a little bit more. So the height right here of this arch is approximately, and I'm going to round, 360 feet. Our vertex, we have just found to be 882,360, and I just rounded that. So think about what we did. We used the negative b over 2a to find the equation of the axis of symmetry, which we know gives us the x value of the vertex. We plugged back in the x value, and using our calculator to simplify, found the y value. In this case, we have now found this height, and we can go ahead and solve the first question here. How high above the river is the arch? So if we want to know how high above the river the arch is, we can just take, and I'll put a 1 here for this question, we can just take the 360 that we just found, plus the 516 that's given to us here, the distance from this line here, this base, down to the river, and that will give us 876 feet approximately that this arch is from the bottom, or from the top of the river. So from the river to this arch, this top of this arch, this maximum point, it is 876 feet. So now we can also figure out our last question. So we have the first one down, how high above the river is the arch? We have done that one. Now we want to know how long is this section of bridge above the arch? Well, if we know that this is 882 feet and parabolas are symmetric, right? This is the line of symmetry. How far is it from here, the middle, to the other side? Hopefully you are thinking 882 feet as well. So for question number 2, we're just going to take 882 feet times 2, or 882 feet plus 882 feet, and that'll tell us how wide that bridge is. So if we add those together using our calculator, bring it back over here, we have 882 times 2, we get 1764 feet. All right, and our problem is done. And all we really needed to solve this problem was to figure out our vertex. Once we had our vertex, we were able to answer all the questions in the problem. Let's try another example. In problem number 2, it says that although a football field appears to be flat, its surface is actually shaped like a parabola, so that rain runs off to either side. And you can see an image of this right here. A cross-section of a field with synthetic turf can be modeled by this equation right here, where x and y are measured in feet. And we want to know what is the field's width and what is the maximum height of the field surface. So again, we have 2 questions that we're trying to find. We have this first one, what is the field's width? And we have the second one, what is the maximum height of the field surface? So we want to know this distance from here all the way to here. So what is that distance? So what is that x? Right, that's an x distance. We also want to know what is the maximum height of the field surface. So we want to find out this point here, our max. And by doing that, we need to then come over here and figure out what the y value is of that max. So if we can find our vertex, then we can find our max. All right. So let's go ahead and get started. First things first, let's go ahead and figure out our equation for our line of axis of symmetry. So we know again that it's going to be x is equal to negative b over 2a. And here is our b, right here. So we have negative 0.03144 all over 2 times our a. And here is our a value in front of the x squared. So that's a negative 0.000234. All right, let's go ahead and simplify this. So let's simplify our denominator first. Let's do 2 times this information. So we have 2, we'll move our calculator back over, times 0.000234. So that gives us a negative, because we have the negative in front, 0.000468. Now let's go ahead and divide those. 0.03144 divided by 0.000468 gives us approximately 67.18 feet. There we go. All right, so now we know the distance from here to here, and that's going to be approximately 67 feet. Now we need to figure out the distance up so that we can find our vertex. So we have half the coordinates, we just need the y coordinate. So let's go ahead and plug that in to our equation. So we are trying to find y. 1, 2, 3, 2, 3, 4, and we're going to plug in the 67.18 in place of our x, plus 0.03144 times 67.18. Okay, so once again, we'll use our calculator to simplify. I'm always going to do my exponents first. 67.18 squared And then I'm going to go ahead and multiply it by the number in front. And I'm going to do that all at once. So I'm going to end up with a negative. So times 0.000234. And I end up with a negative 1.06. I'm rounding to the hundredths place. And then let's multiply this information here. So 0.03144 times 67.18. And I get 2.112. And if I put those together, a negative 1.06 plus a 2.11, that means I need to subtract the 1.06 from the 2, and I get a 1.05 feet. So what we know then is that this height here is 1.052. So our vertex, we write that out, is 67, that's our x value, comma 1.05, and we'll just round to the hundredths place. So basically that means that the football field goes up about a foot at the highest point, so that way the water can drain. So we've answered number one. Oh, nope, we haven't. Number one, what is the field's width? So number one, well, the field's width is going to be the 67 here, plus we know it's going to be 67 on the other side because it's symmetric. 67 plus 67, if we add those together, we get 134. So 134 feet across. And for the second question, what is the maximum height of the field's surface? It's approximately a foot tall, approximately 1 foot. All right, and that concludes our lesson 2.11.b. So hopefully at this point you are understanding that in order to interpret our quadratic graphs, you merely just need to find the vertex from a standard form quadratic equation. And to find the vertex, remember that you just do negative b over 2a to find the axis of symmetry, and that gives you the x-coordinate. Plug that back into the equation in order to find the y-coordinate. And from that vertex, you can find the distance across a quadratic graph, and you can find the height of the maximum.